Yeah, good morning, students. In the last class, we had a discussion on algorithms and flowcharts. Now, in this discussion topic, we will discuss on constants and variables, data types, how we can define a variable. So, those things we are going to discuss in today's classroom discussion topic. So, now I would like to share my screen. So, is my screen is visible? Okay. So the topic for discussion is constants, variables, data types, and how we can declare the variables. Now here, uh, the lecture objectives are that this session will develop the students' knowledge in understanding the uh, differences between how the constant can be declared and how we can define a variable and what is the syntax for variable declaration. So that we are going to understand what the variables and constants are. So generally a constant is nothing but an identifier whose value does not change. That is what we are calling it as a constant. So which will have a fixed value. Okay. So it will not change its value during the program execution. So there are numeric constants, character constants. So under that numeric constants, we have integer constants, real constants. So that is a floating point constants. We can say it as floating point constants. And these are the character constants. Under that, we have a single character and more than one character, which we can call it as a string constants. So single character constants are generally enclosed in single quotes. And if we want to make it as a string constants, generally we will enclose in double quotes. If you enclose in double quotes, it becomes it as a string constant. If you enclose in single quote, it becomes it as a single character constant. So integer constant refers to the sequence of digits, and it can be of three types here. So decimal constant, it consisting of 0 to 9 digits preceded with a plus or minus symbol. So this is example 12 minus 13 like that. So they can be decimal constants. And there is an octal constant, it's consisting of digits 0 to 7, which preceded with 0. This is very important. So the difference between here, if you are writing 12, so it is a decimal integer constant. So if you write 0, 1, 2, now this becomes it as an octal constant. So this is octal constant and this is an decimal integer constant. So try to understand the difference between these two important things. So like this, it is preceded with 0. And the digits which we have in the octal system is 0 to 7. So next hexadecimal constants are there. So it consisting of digits 0 to 9 and then capital A to capital F or small a to capital F, and each will be prefixed with 0 capital X or 0 small x. Okay, so you can identify that. So for example 129, so if you write like this, it is becomes it as a decimal constant, but if you write 0x129, it becomes it as a hexadecimal constant. Okay, so this is also hexadecimal constant, so it will be prefixed with 0x6bc. So next, coming to this real constants, a real constant refers to the sequence of digits with a fractional part and also call it as a floating point constants. Okay. So example 0.98, 1.234 like that. Here 0.65 E4, that is what we are calling it as, this is called it as a mantissa part, and this is after this E, it is called it as an exponential part. This notation is called it as mantissa exponential notation, we can call it as. So now if you take this particular slide, now in this, what are the constants which are valid? Okay, why the constants are, some constants are not valid, why it is? Okay, so if you take this first constant, so it is a valid constant. So it represents if you are suffixing with L, capital L, it indicates that it is a long integer. So if you take the second constant here, you are making use of a special character comma, which is not allowed. So it is an invalid constant. And this is also a valid constant, which is called it as a mantissa exponential notation. So it is also a valid constant. So this is a mantissa 3.5 and exponential is 10 power minus 5. This is. So this is also what we are saying here is that because there is a space between E and 4. So if you don't have a space, then it is a valid constant, but if you have a space, it is an invalid constant. Fine. So this is also valid constant. And then coming to this, another important thing is that here. So it is not a valid constant because exponent is a uh, floating point number. It should not be a floating point number. Always exponent must be a integer value. And here also it is not valid because we are using special character dollar. Fine. So it is a valid hexadecimal constant. Fine. So then if you are coming to this single character constants or a normally called it as a character constant. So which is enclosed within a single quotes just like this. Okay. So if you are enclosing some single character in a single quote, then it is a character constant. Example like this, small a enclosed and star you enclosed here 5. So it is different from a numeric 5 value. It becomes it as a character constant. It is not a number. Fine. So when you are enclosing that in single quote, it becomes it as a character constant. It will treat it as a character. So next, string constant. String constant is nothing but sequence of characters enclosed within a double quotation marks. So example PPSC we have enclosed in double quotes. So all these are valid string constants. Then coming to this, these are the backslash character constants, we can call it as very important. So which are backslash a we enclosed in single quote. So it is a backslash character constant, which indicates that it's a alert, audible bell. Backslash b, which is called it as a backspace. Backslash f, it is a form feed. Backslash n is a new line. Backslash r is a carriage written. Backslash t is a horizontal tab. Backslash v, vertical tab. Backslash single quote. So it is a single quotation, backslash double quote, backslash question mark, backslash, and then backslash 0. This is not like this. This is like this. So this is backslash 0 in single quote. It is a null character. So these are the backslash character constants we are calling it as, because it is always every character constant is preceded with backslash. Okay. So only these are allowable. Okay. If you want to print a question mark on the output, you have to write backslash question mark. Then only you will get it as a question mark output. So if you want to go for new line, backslash n new line. Okay. If you want to print single quote, backslash single quote, you have to enclose. If you want to print double quotes onto the screen, backslash double quote, and you have to enclose in double quotes like that. Alert, backspace, form feed, new line, carriage written, etc. Now the reflection spot here. So what is the difference between a character constant and a string constant? Anyone? So if we are taking it as a character constant, it is enclosed in a single quote. If you are going for a string constant, we are enclosing in a double quote. Then next coming to this, variables and data type. So what is a variable? A variable is nothing but a data item which is used for storing of the data value. Okay, and it should follow certain rules when we are naming that variables. So for example, if you take this, uh, one, a simple interest, area, perimeter, side, radius, etc. These are the variables. So each variable in C language is associated with a data type. Fine. So each data type requires different amounts of memory. So every data type variable will occupy certain amount of main memory, and it depends upon what type of data we are defining. So which data type we are using. And there are some specific operations which can be performed on that particular data type variable. So data type always specifies what type of data that the variable can store, like whether you are storing integer data or character data or floating point data or double data, etc. So the data type is a collection of data with values having fixed values, as well as some characteristics we have. It prescribes what the data types are. So the data types in C is categorized into mainly three different categories. Primary data types, they are also called it as primitive data types or built-in data types. Okay, they are called it as a primitive or built-in data types. We can say it as int, okay, char, float, and then double. And also this void is also there. That is also added here. Okay, simply void. So these are the built-in data types we have, primitive data types we have. And these are the derived data types which are derived from the primitive data types only. Arrays, pointers. Okay, so these are the derived data types, arrays and pointers, structures, unions. These are comes under structures, unions comes under user defined data types. Enum, type def, they comes under user defined data types. So user defined data types are the data types which are defined by the programmer itself. So we can define our own data types. That is what we are calling it as a user defined data types. So derived data types are the data types which are derived from the primitive data types, built-in data types which derive any. That is what we are calling it as a derived data types. So you see that here this diagram shows here clearly. So integer data types are, so we have a signed int, short int, long int, unsigned int, unsigned short int, unsigned long int, and char, signed char and unsigned char. These are character data types. These are integer data types. So these are the floating point data types, float, double, and long double, and this is the void data type. So what is the range of basic data types if you take it as char? If you take it as, its range is minus 128 to 127. Its values range is, so int data type if you take it as, if you are assuming that an integer is occupying 2 bytes in size, 2 bytes of memory, if it occupies that, then the range is minus 32,768 to 32,767. Similarly, float data type, its value is 3.14 e minus 38 to 3.14 e plus 38. Double, if you take it as 1.7 e minus 308 to 1.7 e plus 308. So exponential 10 power 308. Okay, so this is what the range you can get it as. Okay, so generally the range, in general we can write it as the range for any data type. You can take it as 2 power n minus 1 to 2 power n minus 1 minus 1, where n is the number of bits the data type is taking. N is the number of bits the data type takes. Okay, how many, what is the size of the data type in number of bits? N is the size of the data type in number of bits. Fine. So that is the generalized formula. Please try to remember that. So minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. Fine. So this is what the range is. So coming to this variables declaration, how we can declare a variable. So after declaration has basically it tells the compiler that what the variable name is and what type of data the variable will hold. Okay, what is the name of the variable and what type of data the variable will hold. So these are the two important things that the data type is going to inform to the compiler. So the syntax for declaration of the variable is data type followed by variable 1, variable name 2, and so on. Example, you take this, if you want to declare three integer variables a, b, c, so int a comma b comma c. Similarly, if you want to declare three variables ptr as float, you can declare like this. Simple interest is also float, you can declare like this. So assigning values to variables, how we can assign a value to a variable. So by making use of this equal to symbol, that is what we are calling it as assignment operator, you can assign a value to a variable. So at the time of declaration of the variable also you can assign a value. You can see in this particular example, int a equal to 20. Now a is going to be storing the value 20. Similarly, pi, if you take it as, it is assigning the value 3.14 into this variable. Fine. So these are the different types of data types and their equivalent keywords. So char, char, unsigned char, signed char, signed int, unsigned int, signed short, signed long, unsigned int, unsigned short int, unsigned long int, float, double, long double. So these are the different keywords associated with the respective data types. Now this is the reflection spot 2. So differentiate between constant and a variable. Anyone can able to answer this one. Constant is nothing but an identifier whose value does not change, whereas a variable is a identifier whose value will changes during the program execution. Fine. So the lecture objectives are revisited here. So this session is going to develop the knowledge of in students the differences between the constant and variables and the syntax of the variables as well as the data types. So the summary of this today's session is that constants always refers to the fixed values which does not change during program execution. A variable is a data name which is used for storing of the data, and it will follow certain rules when we are defining a variable. So declaration of the variable will tell to the compiler that what is the name of the variable and what type of data the variable will hold. Fine. So now tell me, these are the few lecture level practice problems. So identify which of the following are invalid constants and why. Can anyone tell me what is why this is a invalid constant? So this is a valid constant because it is a floating point constant. So 5x 1.5, this is invalid because x is used here. So this is also valid constant because you can use a prefix with this symbol. So because this is invalid because it is a string, you should not enclose in single quote, you have to enclose in double quotes like that. So is there any errors here? So because you should not use capital, you have to use small. So like this, please try to solve this particular problem. So after completion of this session, you will be able to understand the differences between constants and variables, and also you will know the syntax for declaration of the variables and how we can assign the values to the variables. Fine. So thank you one and all.